Most modern engines start becoming financial liabilities after 150,000 miles. But a handful of Ford engines became so overbuilt, owners accidentally discovered they could survive 300,000, 400,000, even 500,000 miles without ever being rebuilt. And the crazy part is that Ford never intended some of these engines to become legendary. In this video, we're breaking down the only 5 Ford engines that mechanics, fleet operators, and high-mileage owners consistently trust to outlive the truck wrapped around them, including one engine so durable that some people still refuse to sell theirs after 30 years. Number 5. The 4.9-liter Inline-Six, the gear-driven legend. Some of you have been running this engine for 30 years, and you already know what it is. The Ford 300 cubic inch Inline-Six is the engine that mechanics, fleet operators, and long-haul owners point to when asked what the most durable engine Ford ever built actually is. And the field data accumulated over nearly 5 decades of real-world use backs that claim completely. The foundation of this engine's durability begins with its architecture. The heavy cast-iron block features 7 main crankshaft bearings secured by robust 2-bolt main caps. That 7-bearing design minimizes crankshaft deflection under load, preserving the hydrodynamic oil film across millions of rotational cycles. The Inline-Six layout provides natural primary and secondary rotational balance, eliminating the need for internal balance shafts and reducing the lateral side-loading forces against the cylinder walls that commonly cause bore ovaling in V-configured engines. The defining feature is the gear-driven camshaft. By using a direct timing gear interface between the crankshaft and camshaft, Ford engineers bypass the traditional timing chain or belt entirely. That design choice eliminates plastic guideware, tensioner failure, and chain stretching, making the internal mechanical timing assembly virtually immune to wear. The nearly square cylinder geometry achieves peak torque at an exceptionally low RPM, allowing the engine to spend its entire service life at rotational speeds, where kinetic stress is minimal. The real-world proof is undeniable. United Parcel Service utilized this engine in delivery vans for decades of continuous service without requiring internal overhauls. Industrial manufacturers deployed it in heavy equipment, agricultural machinery, and commercial airport belt loaders. The primary maintenance items are cooling system flushes every 30,000 miles, oil changes every 3,000 to 5,000 miles using high zinc lubricants to protect the flat tappet lifter lobes, and a spare ignition module carried in the vehicle to address the one known electronic weakness: the thick film ignition module mounted to the distributor, which can fail under high underhood temperatures. Address those 3 items consistently, and this engine will outlast everything else in the driveway. Number 4, the 4.6-liter modular V8 2-valve, the under-stressed endurance champion. The 4.6-liter 2-valve modular V8 is the engine that built Ford's reputation for truck and fleet reliability through the 1990s and 2000s, and in 2026, it remains one of the safest high-mileage used purchases you can make. Introduced to replace the older overhead valve Windsor small block family, it earned legendary status for endurance within severe fleet operations, law enforcement, taxi services, and long-haul courier platforms. And the reason comes down to one deliberate engineering decision. It was designed to be understressed. The core of this durability is a deep skirt engine block design, where the block walls extend well below the crankshaft center line, paired with cross-bolted main bearing caps. This configuration provides superior structural rigidity, virtually eliminating lower-end twisting under load and protecting the main bearings from uneven wear across hundreds of thousands of miles. The 2-valve, single overhead camshaft setup maintains a clear reliability advantage over its 3-valve and 4-valve successors by limiting total valve train complexity. Avoiding variable valve timing phasers and complex oil control solenoids that frequently fail in more sophisticated modern engines. The engine is further protected by hyper-eutectic aluminum pistons with a low thermal expansion coefficient, enabling tighter piston-to-bore clearances that optimize oil consumption control and minimize cylinder wall scoring over time. The base architecture was so robust that Swedish supercar manufacturer Koenigsegg used the Ford 4.6-liter modular architecture as the structural foundation for its early hypercars, like the 2004 CCR, heavily modifying the platform to support extreme power outputs. Consumer documentation confirms original engines exceeding 300,000 miles of continuous operation with routine service. To reach 300,000 miles, operators must follow a strict maintenance schedule. Full synthetic oil changes at a maximum interval of 5,000 miles minimize abrasive wear on the timing chains and reduce chemical degradation of the plastic tensioner arms and guides. If the timing chain guides show signs of wear or begin rattling between 100,000 and 150,000 miles, the entire timing set should be preventatively replaced with updated components. During spark plug maintenance, plugs must be torqued precisely to factory specifications. Overstressing the aluminum threads is the primary cause of the plug ejection problem that plagued early production models, and any compromised threads should be permanently reinforced using steel inserts. Finally, the original plastic intake manifold should be upgraded to a version with cast aluminum coolant crossovers to eliminate the risk of sudden catastrophic overheating. Number 3. The 7.3-liter Powerstroke Diesel V8, the indestructible workhorse. If you want to talk about an engine that has genuinely earned the word indestructible, the 7.3-liter Powerstroke is the answer. Manufactured by Navistar International for use in Ford's heavy-duty truck platforms from 1994.5 through 2003, it is the benchmark against which every other light-duty diesel is measured. And in 2026, nearly 3 decades of real-world field data confirm that reputation completely. The engine's resilience stems from its massive material density and conservative power settings. Constructed with a gray iron block and cylinder heads, the engine has a dry weight of approximately 920 pounds, providing immense thermal mass and structural rigidity capable of handling high diesel combustion forces without mechanical distortion. Cylinder head retention is exceptionally strong, utilizing 6 head bolts per cylinder to deliver a high clamping force that prevents head gasket failures even under heavy towing loads. That 6-bolt design is the single most important structural advantage the 7.3-liter holds over the 6-liter Powerstroke that replaced it. The mechanical design avoids the complex and unreliable emissions control systems found on modern diesel engines. No EGR valves, no cracked EGR coolers, and no diesel particulate filters. Without these systems, the engine oil remains free of excessive soot contamination, and the exhaust system is free of the thermal runaway scenarios that sideline modern diesels. Fuel delivery is handled by the hydraulically actuated, electronically controlled unit injector system, developed in partnership with Caterpillar, using engine oil pressurized to 3,000 pounds per square inch to drive injector intensifier pistons, generating injection pressures up to 21,000 pounds per square inch. Because the single-shot injectors stroke only once per combustion cycle, they experience significantly less mechanical wear than modern common rail piezo injectors, routinely lasting over 200,000 miles before needing an overhaul. To achieve 300,000 miles, operators must carefully manage fluid quality above all else. Engine oil changes must occur every 5,000 miles, using heavy-duty 15W40 diesel-rated lubricants. Because the HEUI system uses engine oil to operate the injectors, degraded or sheared oil will directly cause injector misfires and accelerate high-pressure oil pump wear. Fuel filters must be replaced every 10,000 to 15,000 miles. The coolant must be flushed every 30,000 to 50,000 miles. and treated with a supplemental coolant additive containing anti-cavitation agents to prevent liner pitting. Operators should also keep a spare OEM camshaft position sensor in the vehicle. It is the most common sudden failure point on this engine and takes minutes to replace if you have one on hand. If you are finding this video useful, hit that like button and subscribe right now. We cover the real-world information that dealerships and manufacturers will not tell you, and it costs you absolutely nothing. Number 2, the 3-liter Vulcan V6, the quiet overachiever. The 3-liter Vulcan V6 is the engine that most people overlook entirely, and that is exactly why it belongs on this list. Designed as a completely fresh metric engine focused on simplicity, low maintenance costs, and total reliability, the Vulcan powered the Ford Taurus and Ford Ranger for over 2 decades and quietly accumulated one of the strongest high-mileage track records of any Ford engine ever produced. Consumer logging confirms multiple instances of these engines operating reliably past 300,000 miles with nothing more than basic fluid maintenance. The engine's durability is rooted in its non-interference design and simple valve train. Operating with a single camshaft located in the block, short push rods, and 2 overhead valves per cylinder, the Vulcan has very few moving parts that can wear out or break. Because it is a non-interference engine, a timing chain failure cannot cause catastrophic contact between the valves and pistons, protecting the engine's core structure from the kind of instantaneous total loss that defines the worst failures in this segment. The Vulcan V6 generates low specific output relative to its internal volume, which limits internal mechanical stress and keeps the reciprocating components well below their material yield limits throughout the engine's service life. The engine underwent several major structural updates over its lifespan. In 1991, it received friction-reduced pistons, a strengthened block casting, and a roller camshaft to minimize valve train resistance. In 1995, Ford introduced a distributorless ignition system utilizing an electronic coil pack, paired with an updated intake manifold and modified cam timing. Flexible fuel variants were also produced with hardened valve seats to handle both standard unleaded gasoline and E85 ethanol blends without accelerating valve train recession, a durability upgrade that benefits all driving conditions, not just ethanol use. The Vulcan's one critical weak spot is the camshaft synchronizer, which replaces the traditional distributor on later models to drive the oil pump. If that bearing fails, it stops spinning the oil pump drive shaft, causing an immediate drop in oil pressure that will quickly destroy the engine's main bearings. The synchronizer should be replaced preventatively every 80,000 to 100,000 miles. Any squeaking or chirping from the assembly requires immediate replacement. Lubrication changes must be completed every 4,000 miles, using a slightly thicker viscosity like 10W40 in high-mileage applications to maintain oil pressure and control minor leaks. Keep the cooling system clean and free of rust or mineral buildup, and this engine will reward you with decades of trouble-free service. Number 1, the 6.2-liter Boss V8, the modern iron giant. This is the one. The 6.2-liter Boss V8 is the most capable, most durable, and most underappreciated engine on this entire list. And in 2026, it stands as the strongest argument for buying a naturally aspirated gasoline engine in a heavy-duty truck application. Introduced in 2010 to power the Ford F-150 SVT Raptor and heavy-duty Super Duty trucks, the Boss was engineered under the internal prototype code name Hurricane to directly challenge General Motors' large displacement Vortec engines, and it was built with one explicit priority: long-term structural strength under sustained heavy loads. The engine block is cast iron with a deep skirt design and cross-bolted main caps, the same overbuilt bottom-end philosophy that defines every engine on this list. The defining structural advantage of the Boss V8 is its wide 4.53-inch cylinder bore spacing, significantly wider than the earlier modular engine series. That extra width accommodates large cylinder diameters and larger valves, 2.10-inch intake and 1.65-inch exhaust, creating excellent high-lift airflow without needing highly stressed turbochargers. The valve train uses a single overhead camshaft configuration with 2 valves per cylinder and roller rocker shafts, striking a balance between modern efficiency and mechanical simplicity by avoiding the dual overhead cam setup that multiplies moving parts and potential failure points. Inside, the engine is built with heavy-duty components throughout: a forged steel crankshaft, high-strength forged steel connecting rods, and lightweight aluminum pistons, ensuring excellent resistance to structural wear under sustained load. The dual equal variable cam timing system, driven by a crankshaft-actuated gerator oil pump, continuously adjusts both intake and exhaust timing together across different RPM ranges, optimizing low-end torque for towing while maintaining smooth operation at highway speeds. In 2017, the architecture received modified camshaft geometries and updated powertrain control calibrations to increase torque output, mating the engine with Ford's heavy-duty 6-speed automatic transmission. The durability of this architecture was demonstrated in severe off-road environments when a stock bore and stroke version completed the Baja 1000 race in the Raptor R prototype vehicle. To preserve the engine's durability up to and beyond 300,000 miles, operators must maintain a consistent service routine. Engine oil and filters should be changed every 5,000 miles using high-quality oil to keep the variable cam timing phasers clean and operating smoothly. The 16 spark plugs, 2 per cylinder, should be changed every 60,000 to 100,000 miles using premium iridium components to ensure clean combustion and prevent misfires. At high mileages, operators should listen closely for any unusual ticking or rattling from the valve train. If detected, the valve springs and timing chain assembly should be inspected immediately and replaced if worn. A broken valve spring can drop a valve into the cylinder and cause catastrophic engine damage, and catching that failure early is the difference between a $500 repair and a total engine loss. The pattern across all 5 of these engines is consistent and clear: low specific power output, heavy cast iron construction, simple valve train configurations, and a complete absence of the complex emissions and fuel-saving technology that defines modern engine failures. These 5 engines prove that long-term durability is not achieved through turbochargers, cylinder deactivation, or advanced electronics. It is achieved through conservative engineering, robust materials, and simple proven mechanical design. Whether you are buying used, restoring a classic, or choosing between engine options on a new truck, these are the 5 Ford engines that will still be running long after everything else has been rebuilt or replaced. Like this video if it helped, subscribe for more honest truck content, and we will see you in the next one.